Hello students, how are we? Now this day is our second lesson of chemistry. I hope your notebooks are with you, everyone. Now I will not forget to remind you of my name. My name is Wanyama Joseph, a teacher of chemistry, and I remember the first lesson that we had. We were with you and we studied about the chemistry and society. Now I want to proceed with the next topic, but before we look at the next topic, we say the topic 1, as a reminder, was chemistry and society. You remember? Remember that? We were together, look at chemistry and society. Now, I would like somebody to remind us what we covered in this first topic before we start the second topic today. Can remind us? Yes, Patience.
We covered the nature of chemistry.
We looked at the nature of chemistry. Briefly, just summarize up everything.
We studied also what we studied in chemistry, the meaning of chemistry, chemistry in the real life, relationship between chemistry and other subjects, contribution of chemistry to our economy, and why we study chemistry.
Thank you, Patience. We appreciate you are very, very attentive. Now today we are introducing the new topic, second topic, topic 2, and this will be experimental chemistry. Experimental chemistry. Now, before we look at experimental chemistry, I would first request somebody to remind us, what did chemistry mean? What did we mean by the nature of chemistry, so that we can push ahead with the next lesson? What is the nature of chemistry? In simple terms, what do we study in chemistry, and also how could we define that subject? Somebody who was in the previous lesson, because we want to jump to this one.
Chemistry is the study of matter and how it behaves under different conditions.
Patience, you are doing a great job. Chemistry is the study of matter and how it changes under different conditions. Thank you very much. Now, in this second topic, we also have a number of subtopics. We have a number of subtopics, and the first subtopic here, like we did in topic 1, we had some 5 subtopics here. Now here we also have some subtopics. The first subtopic here is we are going to see chemistry as a laboratory science. Chemistry as a laboratory science. Laboratory science. Then we shall also see the first chemistry as a laboratory science. Then we shall see scientific method. Then the next one, we shall also look at the laboratory. What is a laboratory? What is a laboratory? What is a laboratory? Then we shall also see what's a laboratory. We shall also look at laboratory rules and regulations. So, then we shall also visit safety symbols in the laboratory. Safety symbols in the laboratory. Then we shall also look at the laboratory apparatus and their uses. Laboratory apparatus and their uses. Then, upon visiting that, we shall isolate a few important laboratory apparatus, like volume measurement, because it has some technicalities in volume measurement there, how you handle apparatus, which one is more accurate. See, which one is more accurate, and also the units, see, volume measurement. And we shall also see mass measurement, mass measurement. Then we shall finally look at putting off fire in the laboratory. Putting off fire in the laboratory. And that will mark the end of this topic called experimental chemistry. Now, the first subheading here is chemistry as a laboratory science. Indeed, is chemistry. And what do we mean by as a laboratory science? Now, let's isolate that subheading. Chemistry, can put that down. Chemistry, the first subheading, chemistry as a laboratory science. Now listen, pay attention here. Now briefly listen, so that you'll be the ones to answer why the subject is a laboratory science. Now, we say that first in topic 1 that science meant the knowledge. If you recall, science meant the knowledge of the environment based on observation. Are you listening? Based on observation, recording data, interpreting data, using specific methodology. That means you can't use a specific methodology if you are not doing what we call an experiment. Now, that science would mean the knowledge that you can acquire about your surrounding when you conduct an experiment. See, when you conduct an experiment, and in this experiment, you must record information, you must interpret, you must observe, you must analyze the information. Now, that's why we are emphasizing that chemistry is a laboratory science. See, now, upon that discussion, because chemistry is a science, indeed we saw it, because science, we said it is divided into several other subjects. So, now, from that simple discussion, what would you mean if somebody said chemistry is a laboratory science? Because I've said the science is any knowledge of the environment that somebody can gauge by observing, recording, interpreting, analyzing information based following certain methodology. And that methodology, we are saying it's an experiment. Experiment. Then what would you mean by chemistry as a laboratory science? Let me see somebody who can think and listen. Why could we say it is a laboratory science? Anybody trying? Yes, Lemero. Lemero wants to try. Let us see.
Can also be applied in the laboratory.
Okay, good try. It can also be applied in the laboratory. Trial, good trial. Yes.
From what we see, that chemistry is one of the sciences that we have. We are saying that chemistry is a laboratory science because after knowing what science is, that it is the knowledge of the environment based on observation, interpretation, recording, and many other things, using specific methodologies. So, chemistry, we have, we cannot do very many things, basing on our knowledge in chemistry, we cannot what we call the observations, interpretations of our observations, we record that way, and very many things involved in our activities in the laboratory. So, making chemistry a laboratory science.
You are almost there. Something small is missing. Yes. Clears 100% doubt.
I think chemistry is a laboratory science because chemistry, first of all, is a branch of science, and the experiments carried out in
Say it again.
chemistry is a branch of science, and the experiments carried out in chemistry are carried out in the laboratory using laboratory apparatus.
And the experiments carried out in chemistry are done in the laboratory.
Yes.
Say it again and we sum up that.
The experiments carried out in chemistry are carried out in the laboratory.
Why it is called the laboratory science? He means only one thing, that there are experiments. Thank you very, very much. Now, that means you have noted it down, that why is chemistry called the laboratory science is simply that it must involve observations, interpretation of information, and analysis of information, which involves carrying out experiments. Great. Thank you very much. Now, this subheading is finished. Clear? Now, jump to scientific method. I've paused from there. Listen. Now, listen. We said chemistry is a laboratory science simply because it has experiments that are done in the laboratory. Now, if it has experiments, now the method that we conduct those experiments by is a scientific method. Now that calls in the scientific what? That means you will follow very, 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 very well here. Scientific. I'm going to ask who can define a scientific method in regard to previous information. Now, I've said chemistry is a laboratory science. Fine, not so? Why? Because it has experiments done in the laboratory similar to other sciences. Now, and we have said that when you are conducting an experiment in the laboratory, then the method you are using is called a scientific. But as Paulo was trying to explain what happens during the conducting of science. Now, I will pose a question. What would you think a scientific method is based on Aspolo's suggestion? Aspolo, could you echo us back at what you said? Why you were saying chemistry is the laboratory, but there is something you mentioned that was speaking of this method.
Okay, see that in chemistry, as we are carrying out our experiments, we include, because now science is telling us that it's the knowledge of the environment based on recording, analysis of information, and observations. But now in chemistry, we are seeing that when we carry out our Okay, our practicals, we see that we make observations, we make analysis, and we also record our results for anything that we do.
That means we are using the scientific what?
Methods.
Now, wait a bit. Now listen. Let me pause this scenario, and we shall now totally summarize what the definition of this method is and the steps in the method. See, now a boy found a tin of sugar containing, listen to this scenario, a boy found a tin of sugar containing bean seeds and wanted to know how many bean seeds were there. Could you state the steps the boy followed to know the number of bean seeds? Let me see one of you. Systematically, be brief. He did this, step 2, this, short words. Let me repeat. A boy found a tin of sugar containing bean seeds, but wanted to know how many bean seeds were in the sugar. How did the boy find out the number of bean seeds? Now we are on the scientific method here. Again, patience. Okay, chance again to patience.
I think the boy had to first salt the sugar, he puts it in another tin
Sorting.
and left the beans in one tin so he was able to count the beans.
It was a bit, use short words like sorting. Continue. What did the boy do?
After sorting, he had to count the beans.
Counting. Let's try. Only that? Okay. What's a different approach? Yes. Juko, what did the boy say? What did the boy do?
I think the boy first dissolved the contents in the bottle.
That means dissolving in water. Okay.
Then he filtered.
Filtered.
So the recipe that remained behind was the beans because they are insoluble in water. That's why they remain
Then after filtering he counted.
Yes.
Okay. Now what if the boy wanted to drink the sugar to put in it? Where would the boy get the sugar? Or put in mandazi? See, that means sugar has been lost. That's one of the methods that we are using. There are several. Okay, another one.
Sorting. Where you first sorted the beans from the sugar.
Okay, thank you. We are following, yes, her method. The other man, yes?
Pour out the beans and the sugar together on a flat surface. Then he picked out the beans, leaving the sugar.
Thank you. Now, because of time. Now, all that the boy was doing was, he was experimenting. But I didn't notice one thing. What did the boy first saw? Not so. Didn't he observe? Did he first start by sorting? No. He first did what? Observe, not so. Now, after observing, didn't he ask him, so you started to do this thing. You ask you how many bean seeds are here. That means the boy did what we call what? Questioning. Not so. Then he too, what did he do after questioning himself? You see, Pesh is saying he made a theory, but after questioning, then you must first guess and say there might be 100. Not so. That means we call that process state an assumption. Assumption is what you assume. The assumption is called what? Hypothesis. Hypothesis is what? An assumption. Pesh is saying a theory. That is state a theory. Don't state a theory, you first state a hypothesis. Then after that, because the hypothesis you are saying now, maybe there are 100. Then now, you go on to the next stage that you said sorting, which we are now calling what? Experimenting. Then after experimenting, what happens? Do you conclude? After sorting, sugar is there, bean seeds are there. What? And that's now count. That's still what? Then you what? Can't you interpret and analyze? Interpreting and analysis. You know, there are now 100 by using eyes analysis. Then lastly, you make a conclusion. Yeah, thank you. Now that's what we call a scientific method. It is a method that involves questioning, involves observation, involves experimenting, stating hypothesis, and interpreting, then conclusion. Now, could we say, who can now define for us what is a scientific method of study in conducting scientific experiments? Who can try based on this discussion? We don't have enough time. Remember, we are now dropping here. What is a scientific method? Guys, you are leaving the thing for me only. Let us reason together. Who can try? What is a scientific method? My thinking has ended. Lemmer, what's a scientific method? Okay, Patience, try for us.
I think scientific method are steps taken to experiment something to find a solution for it.
Okay, good try. Anybody else? Shall I say that scientific method is a method of experimenting, not so? Okay, go ahead. Lastly,
I think a scientific method is an experiment that is done by an observer a scientific method is an experiment that is done by a person to interpret an observation in the laboratory.
Okay, thank you. Now, in summary, a scientific method, maybe you can note down from our conclusive discussions. It is a method of conducting scientific experiments. A method of conducting scientific experiments that involves observation, questioning, stating hypothesis, open bracket assumption, making analysis and conclusions, full stop. Now, making analysis and conclusions. Now, I think that was a bit a tug of war. That has taken us now to subtopic 3 called the laboratory. Now we have been seeing all along. Now in discussion, what's a laboratory? I would think that a laboratory, everyone knows it, not so? I would think so. Now, before you look at a laboratory, let me pose a question. Give me some few simple experiments that you can carry out and the places where we can carry them out. Some 2 experiments. Maybe group 1 give me one, group 2 give me another. 2 experiments that we can carry out and the places in which we can do them from. May I give you a simple experiment of mixing bean seeds with the sugar. Then I could want some 2 from you. Some 2 experiments and where they can be conducted.
No, they can't.
Anywhere. Okay. 2 experiments and where they are conducted. Yes, Aspolo?
You can separate sand from salt.
Separating sand from salt. Yes, where can you do that from?
You can do that at home.
At home. That's very good. Another one?
We have,
You have 2 more?
we have, yes.
2. Go ahead.
The first one is dissolving sugar in tea.
Dissolving sugar in tea at home.
And another one.
When you cook, then the aroma that comes out, how does it hit you?
Diffusion.
That means you are conducting a diffusion experiment. Not so. Say it again loudly. They have not picked.
When you're cooking at home, the things you're using to cook and the kitchen, maybe in the sitting room doing other things, then how does that aroma reach you? That's strong thing.
Okay. Thank you very much. Thank you. Now, in brief now, when we are in the laboratory, experiments in chemistry now would be done where? In the chemistry laboratory, not so? Then, who can, in simple terms, could you give us a favor and define for us what's a laboratory now? What's a laboratory? Yes.
A laboratory is a scientific room where all science experiments are conducted.
Okay. Is a special room where all science experiments are conducted. Is that very, very right? Somebody with a different view? You can see a hand.
A laboratory is a special room where scientific experiments are carried out and apparatus are kept.
I think that additional information is very good, and where apparatus are kept. Thank you very much. Now, thank you very, very much. You are good students. Look here now. Now, you said that we came from chemistry as a laboratory science. We saw that it was the reason it was this is because it involves experiments, not so? Then you said each experiment is done using the method called scientific. Then the experiment is done in a place called, which contains some instruments called upper. Now let us jump to laboratory rules and regulations. I think you are being very, very good candidate. Very, 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 very good. Let us try it and regulations because of time. We have strictly one. Now look there. laboratory rules and regulations. Listen to this scenario. Are you listening? Now the scenario goes, a boy, are you listening? A boy was requested to go and prepare a salt solution in the laboratory. Are you listening? Then the boy who was seated in class wrapped a sweater around his waist. He wrapped a sweater around the waist. Then picked his books and ran very, very fast as he could to the laboratory. No sooner had he reached the laboratory than he knocked a glass containing a colorless liquid. Are you listening? The glass fell down and broke, and the liquid is spilled. Clear? Now, the books fell in the colorless liquid, and the girl bent down to pick the broken glass in fear. The colorless liquid began burning the books. Then when the girl was picking a glass, it cut her fingernails. It cut her fingers. The girl ran to the tap to wash. When she was running to the tap, her sweater knocked hot water that was on that was boiling on a Bunsen burner. The water also burnt her. Clear? Have you understood the story? We repeat. You've understood the story? Then the questions that go to you. Which mistakes did the boy make? Everyone, one answer. Which mistakes did the boy make? Yes, Pensius, as we move. Carrying books to the laboratory. That's mistake number one. Yes. Tying a sweater around her waist. Okay?
Running or rushing where in the laboratory?
Running to the laboratory. Going to the laboratory without supervision. He left the teacher behind. Then another one, Pensius, continue. Picking up broken glasses without, meaning the boy should have reported to the teacher first. Okay?
So attempt to touch in that liquid with bare hands, not covering lady glasses.
Not covering yourself with safety gloves. Not so? How many more are many? Now, thank you very much. Question 2. How could the boy have avoided the accident? Oh, how could the boy have avoided? What happened? Yes, start again, Pensius.
By going to the lab with the supervisor or a lab technician.
Going to the laboratory with the supervisor or laboratory technician.
By covering myself with safety wear.
The boy should have covered himself with safety gloves and wares. Okay, next.
The boy should not tie the sweater around his waist.
The boy should not tie the sweater around his waists. Okay, the other man. A boy should not have carried books to the laboratory. Thank you, Patience. And lastly, then we move.
The boy should have first read the lab rule, the laboratory safety rules before entering the laboratory.
The boy should have read lab safety rules and regulations. Thank you. Juko, you have another one?
By going to the lab with
By going to the lab with
the supervisor.
the supervisor? Okay, thank you very, very much. Now, let us try to, I think in our discussion, we have been, what have we been discussing? Simple laboratory rules and could we list in, let me give you 5 minutes, you discuss per group, then we have 2 people presenting, some 3 laboratory rules and regulations, 3. Can you now try to compare their similar observation, their similar answers?
Yes.
Take a similar answer. Then conclusively, let me have group 1 present the Patience and Juko. Present, one person present to us the laboratory rules and regulations, 3 points only. Then this group don't repeat. Okay, go ahead, Juko.
Point number 1, no rushing in the laboratory because you can easily knock anything, like in the example where that was restated that this girl unintentionally knocked that bottle on a colorless liquid. So point number 2, you should not enter without a supervisor.
Okay, without a supervisor. Finish up.
Then point number 3, not eating anything in the laboratory. Attempt to do so.
No eating anything in the laboratory. Okay, let us have group 2.
What they have not talked about, we are saying that do not touch any unknown chemical in the laboratory. Now, for example, that boy, you want me to just study the chemical that on the board, not knowing that because he did not know the effect of that chemical.
You mean you should touch when they have told you to touch?
At least when you know what that chemical is after the lab technician or the teacher telling you. Then we have also discussed that do not carry out unsupervised experiments in the laboratory.
Thank you very, very much.
And also do not carry your books to the laboratory because it's what happened to these boys' books since he carried them to the laboratory.
I think we have been very, very elaborate. Now let us echo through them very fast. No rushing to the laboratory or running to the laboratory, not so. Point 2, should not enter the laboratory without the teacher's supervision or lab technician's supervision. Next, no eating anything in the laboratory. Next, echo for me then.
Do not touch unknown chemicals in the laboratory.
Do not touch any unknown chemical in the laboratory.
Then do not carry out unsupervised experiments in the laboratory.
Do not carry out any experiment without being instructed by the teacher. Thank you very, very much. Now, I think that's all. Let us jump here. Safety symbols. Safety symbols. Now, in the discussion of a safety symbol, I brought this bottle. The bottle is written on methanol. Methanol, and it has some symbols here. Here, there is this. There are so many, but I've only brought this. Have a look and probably give the meaning. Pass around. I think you picked the meaning. I want answers. Safety symbols. Okay, now let me receive answers now. Some symbols, yes, penitence. Are you looking at the first symbol? Which symbol are you talking about? First one, second one?
The second and the third.
The second one and the third one. The second, what does it mean?
Highly flammable.
Highly flammable. That means this looks like fire. Okay, highly flammable. Then next?
It's dangerous.
It's dangerous. Dangerous, what do you mean by to be dangerous?
Like that chemical is not supposed to be, let me say, it's not supposed to be withheld by someone, because you might use it accidentally and it may spill, and then you take maybe a matchbox and you, let me say, light it out of the blue, and to cause danger to people around you, and
it is dangerous.
yes.
You wanted to say something.
I think some other thing about the dangerous thing.
But you are in line with her.
Yes. It being dangerous, it should not really be taken into the body.
Say it again. Say it again. It should not be drunk. Thank you. But you are refusing to say it should not be drunk. Now there are a number of safety symbols, but we have seen they have elaborated on two. The one that looks like fire, not so? This you say it means what? To be flammable is to easily catch. Then we saw this one was the skull, like the skull of a man with eyes. I don't want. Not so. This meant what? That it is what? The chemical was toxic or what? Dangerous. Okay, you'll find out so many of them, but for the meantime, for the interest of the lesson, let us have only those. Now, we are now jumping very fast to our next subtopic called laboratory apparatus and their uses. Laboratory, have that one written down very fast. Laboratory apparatus and their uses. And their uses. Now you prepare to discuss the uses and their uses. Apparatus. Then the diagram. Then the use. Now listen briefly. We started here and said that chemistry involves conducting an experiment, and the tools to conduct the experiment we now call them laboratory apparatus. Now we are going to look at one by one. The diagram, I'll give you time. When the lesson ends, you draw. But for the meantime, we shall state an apparatus. Yes, and its use, not so?
Yes.
Now, we start. We start with what's in front of us here. I think we start with what? We start this side going like this, not so?
Yes.
When I lift up, you'll help me, because you might be aware of some. Now, I remove this first, hold this. Now, this is the first apparatus. Yes, first apparatus. What's the name of this apparatus? It is called a test tube rack. Test tube rack. What does it do? Yes, Juko, Lemero.
Used for holding test tubes.
The test tube rack is used for holding test tubes. Fine. Then could you show us a test tube? Now that is what? This is called a test tube, not so? A test tube. What is the use of a test tube? A test tube. This one. Yes, let us hear from him.
It's used for...
Hold it.
This test tube is used for mixing or carrying out simple experiments in the lab.
It is used for carrying out simple experiments in the laboratory. Like what?
Like separating of mixtures.
Like separating of mixtures using what? A filter? A filter paper. Now, he has said that simple experiments, we can just get one substance, add it to a test tube, then add in a liquid. And that means you are carrying out a simple experiment. Thank you very much. Now, that's called a test tube. You held another big one. The big one was called a boiling tube. What is the use of a boiling tube? Boiling tube. Hold it, patience.
It is used for boiling substances in the laboratory.
Used for boiling substances in the laboratory. How do you boil a substance?
Well, the substance into the boiling tube. You get a Bunsen burner, which is used for heating. You get a Bunsen burner, which is used for heating. You get a tripod stand. Place the Bunsen burner under it. Get a wire hose. Then you get this test tube holder.
Lift it up first. This is called
A test tube holder.
test tube holder. To hold the test tube during what? During heating.
Then you light the Bunsen burner and then you start heating. Like this.
You start heating. Is she very perfect? She's not perfect. What's her problem? What's her problem?
I think when you're heating,
When you are heating,
like using that boiling tube, I think when I'm heating using this boiling tube, I won't need the wire hose and this stand. Bunsen burner can stand alone.
you won't need these two.
Yes.
You would put it in space on the hottest part.
Yes.
Okay, thank you very much. Patience, have you learned that? Now, the next part, we look at this instrument here. Somebody will demonstrate how we use it. It's called
A stop clock.
stop clock. For measuring?
Seconds.
For measuring?
Second. Time.
A stop clock is used for measuring?
Time.
For measuring time, not so? Now it is written on second time. It measures in seconds. It measures in seconds. Now, somebody knows how to read it? Move it a bit. Yeah. This man is very much willing. Move it. You move, let it move a bit and point and stop it somewhere. Okay, we are waiting. Now you read for us that time. Point it here and they see.
Look at the number before this hand, and then this number, you count these lines here after it. This is 1, 2. Now these short lines, they are halves. So it's 5.12. Sorry, it is 5.5. Then 5.6, then 5.7, 5.8, then 5.9.
Is it right? Face it to them, they see. Try to hurry time.
Okay. This previous one before. Okay, the numbered portion of the step clock before this time hand here, it is labeled 5. So to count the time that it has been stopped at, each of these small ones is 1 second. So this is 5, the next one is 6, 7, 8, 9, and the next one is 10. But now here, it stopped at 9, so it is 9 seconds.
9 seconds.
Yes.
Point it to all of them. Not point, as you are saying. No, we don't say point. Point would just be because it has 60, a small one then like that, not so? Then longer one like that. That means when you are here, like when you are here you would say 1, not so?
Yes.
Then here, what would you say here?
2.
What of here? Are you sure? Let's look at that stop clock very, very, very. It would be 1 point. The small one is a 0.5.
Yes.
Then this is 2, not so?
Yes.
Thank you very much. Okay, the stop clock we have ended. Now, because of time, let us try to hurry. We have this. This is called triple beam balance for measuring mass of substances, not so?
Yes.
Okay. Time can't permit us. Next, here we have measuring cylinder. We have so many. We have this. We have various what sizes? Measuring cylinder. Okay, now this one is also called a measuring cylinder, not so? Now I would like let us put all those volume apparatus together. Put this measuring cylinder, not so? Then this one is called a beaker. Okay, then this one is called flat-bottomed flask. You're very, very sure?
Yes.
Now let us lift one by one. This is, and they are of different sizes.
Yes.
One can be glass, one can be plastic, not so?
Yes.
Okay. This is called, all of them are for volume. This is called, now, unfortunately, let us also have this. This is called conical flask. Look here. Somebody is saying, I want you to really listen here very, very much here. Now, look here. This one here You see, we have a flask like this. It's unfortunate I didn't bring it. Then we have another one like this. Not so? Then we have this one with a long neck. And this one with a long neck has a label here. Look here. This one would do. This one here, we don't have it here, unfortunately. This one has a big mouth like this. But this one with a neck here has where you end. This is called a volumetric flask. Then this one is a flat bottomed. This is a round one. We didn't have them here, but incidentally, they are different, not so? Now, fine. This is a volumetric what? Flask. Now, let us try to, you give me their uses particularly. What is the use of this one? Measuring cylinder does what?
Measures accurate volume of water.
Let us hear from her. Measures?
Accurate volume of a liquid.
Measures accurate. Let me fast forward that answer. I will not accept it first. Then this one measures.
It measures the volume of the liquid.
Measures the volume. What of this? Yes, volumetric flask patience, you are trying again. Now, listen here. There are some apparatus among these which are very accurate and measure only one single volume. This can measure a variety of volumes. Not so? Can measure as long as you come from down and put anything you want. But this has only one volume written here, called 250 mils. This measures fixed volumes. And let me be very, very specific. This measures fixed volume and very accurate. This is the most accurate apparatus called a volumetric flask. This one, these two also measure volume. This one also measures fixed volume because it is written on only 25. They can be of any, they can write on 25, 10. What they write on is what it measures. And it measures specific volume. The most accurate apparatus is which one? Volumetric. Then the next in accuracy are these ones. These ones measure inaccurate volumes. They are used when you don't want a high degree of You understand? Okay. Now, let us go ahead to pick another apparatus about approximate volume is also here. Thank you very much. A beaker also does not measure volume accurately, approximates volumes. Clear? Okay. What is the use of this? What's the name of this? Test tube brush. Test tube used for washing test tubes. Fine. Now, jumping very fast. What of this?
Spatula.
This is a spatula. You hold this wide end is the handle. Then the smaller end is used for scooping. It's called the spatula. Then this one? Test tube holder to hold the test tubes during heat. Now we have this. What is this? A dropper used for transferring chemicals. transferring small amounts of liquids or solute. How do you use it? Let me see somebody using it. Use it and they see it. You transfer 2 drops here. Show us how you picked the drops.
First, you get it and you place it into the...
And you?
Place it into the liquid. Then you press here.
You squeeze the handle.
Yes, you squeeze, then you let go.
You squeeze and let go and release, not so?
Yes, and the liquid will enter. So it depends on how many droplets you want to transfer to the other container.
Yes.
So right now I want to transfer 2. So you just press lightly.
Okay. Yeah.
That's 1.
That's true. Thank you very much. Now we have this. What is this? Wire gauze. 4? Yes, lemero.
Spreading heat.
Spreading heat on a tripod stand, not so? Oh, I've already mentioned this one as a tripod what? Stand, not so? Okay, thank you very much. What is this? A Bunsen bar used for heating purposes, not so? Now, I think we didn't talk about this. What was this? These 2 are together. This is called triple beam balance for measuring masses, not so? This is called electronic weighing scale, also used to measure masses, but we put it in the power point, then switch on, then put what we want to weigh on this. Clear? Okay, because of time. Kali, now I think we've exhausted everything. Now, specifically, we've gone through many. Let us try to when I mention, you mention the use. I mention each apparatus. Okay, let me, we have this one. Yes, what do you call that one? Yes? This is called a Petri dish. Put in chemical solid substances. We put for you solid. That's right. Now turn here very fast. We are going to mention one by one. When I lift, you mention the name and the use.
Measuring solid.
Volumes of liquids. Test brush. Washing is a test tube.
Washing test tubes. Test tube holder. During heating. Tripod stand.
Containers that are heated.
For holding what? Containers. Not so. During heating. Not so? Yes. Okay. Now, turning very fast. Now, look here. We are turning on to this volume apparatus, volume measurement. Then we summarize mass measurement, and finally putting off fire. And that will be our lesson for today. Now, volume measurement. Let us particularly look at apparatus for measuring volume. I don't know whether you will. Now, we said volume measurement, we are going to look at accurate volume. Which one do you use for accurate volume? And the one for approximate? Inaccurate volumes. Inaccurate volumes. You have said here, what are they here? Yeah, we use a volume. Which other one? Volumetric flask. Then we said here, pipette, burette, not so? Then here, we have the measuring cylinder, what else? Conical flask, beakers, and what else? Are you sure?
Yes.
Labels. We shall not let us hold the dropper. Now listen here. Look here very, very well. Look here. We are going to demonstrate how we use each here. Very, very well. Now, each volume apparatus has where it starts. Look here very well. When you are looking at any instrument, it has what we call calibrations. Calibrations are those markings or labels. Clear? Now, in those labels there, when you pour there the liquid, some liquids will bend like this. Clear? While some liquids like mercury will bend like. Now, when you are reading volume on any apparatus here, you read the bottom of the liquid. We call it the lower meniscus. This is upper meniscus. This is lower meniscus. You read from the bottom. That means, give me some. Now look here. I'm demonstrating this very, very fast because of time. Now, like my liquid has ended here, but you can see there is a curve. There is a curve where the liquid has ended. You don't look at where the upper part, but you look at the bottom of the liquid. Pass it around, look at that lower meniscus. Lower meniscus. That bottom is what we consider, not the upper. Is that clear? Now look here. All of them I've told you to read the lower what? Meniscus, not so. Now, I want to try it what? I want you to look at, pick a measuring cylinder there and look at something on it there. Look at what units on the volume apparatus there. Is it a unit on volume apparatus? What are you saying? What are you saying? What units are you saying? You are saying milli? Milli what? Liters, not so? ml, not so? Now, we are saying milliliters. Now, there are always other units in this apparatus. We have milliliters, we have liters. Listen, we have cubic decimeters, which is dm cubed. Then we have finally cubic centi. There is the last one called cubic what? Cubic what? Cubic meter. Now listen, I'm summarizing. Listen. Now, most of them are labeled milliliters. That clear? Milliliters. Now, milliliters is the same as cubic centi. Clear?
Yes.
When we say 1 milliliter, we mean 1 cubic centi. Now, Some are labeled in liters. For big apparatus, we always use liters and decimeters. What? Like our jerrycans of 20 liters, we don't say 20 centimeters cube. No, you will always hear 20-liter jerrycan because those volumes are big. For big volumes, you use liters or decimeters cubed. Fine. Or sometimes they use cubic meters for large volumes. Now let us try to, I think that's understood. Clear? Now we are still on volume here, and we are still on volume. We are still on volume. Now let us try to summarize for the interest of time in this lesson. Now lastly, let us look at putting of fire in the laboratory. That will be the end of our lesson. Now, putting of fire in the laboratory. What instrument is used to put off fire? Fire extinguisher. Extend that fire extinguisher here to demonstrate how it is used. Anybody knows how to put out fire using a fire extinguisher? You know. Okay. Even this man knows. Can you demonstrate from there? It is, you know how to demonstrate? How it works. You can demonstrate. Now, because the instrument is not working right now, just demonstrate and they see how it can be used. You demonstrate.
Now when there's a fire outbreak, let's start using this
nozzle.
Then you point it in the direction of the fire.
You point what?
You point it in the direction of the fire. So there is this string here. So you unclean it. So
you pull the pin.
Yeah. You pull the pin so that you can press with ease.
You press the handle.
The handle with ease, letting out the carbon dioxide to put out the fire. Then here there is a small scale to read the amount of gas remaining in the cylinder. So then after putting out the fire, you can bring this one back here so that when you press it does not go down by mistake. Then you bring back this one, then you hang it where it is. It can easily be reached in case of
Okay, can you repeat those steps? We have told you that this one is called the what? The nozzle. This one is called the pin. This one is called? Give us clear steps.
So, I'm using the nozzle, pointing to the fire direction, unpin the pin, so that you can easily press the handle. Then press to let out the gas, the carbon dioxide gas in the kitchen. Letting it through the nozzle and to the fire. Just put the lid out.
Okay. Yeah, thank you very much. Yeah, now in summary, we have finished our lesson. Listen very attentively. Listen. We have finished our lesson for today. Now, I'm giving you what we call activity of integration that you will bring in the next lesson. We shall mark it and award marks, and you receive marks out of 10. Clear? Now, our activity of integration, write it down for the end of this lesson. Write it down, activity of integration. As the question goes, as a student of chemistry, prepare a brief message to deliver to new students. Prepare a brief message to deliver to new students On Y, semicolon. On Y, semicolon, we mean this. We mean this. On Y, semicolon A laboratory is important in the study of chemistry. A laboratory is important in the study of chemistry. A laboratory is important in the study of chemistry. Then part B, why you should not enter the laboratory without the permission of the teacher. Why you should not enter the laboratory without the permission of the teacher. Lastly, why it is important to consider safety precautions and laboratory rules. Why it is important to consider safety precautions and laboratory rules. Also, have you put it down? Finally, in summary, we looked at the next topic called experimental chemistry, not so? We saw chemistry as a laboratory science, and the reason was because it involves experiments in the laboratory, not so? Then we saw what's a scientific method, a method used in carrying out scientific experiments and must involve observation, things like interpreting information and conclusions, not so? Then we saw a laboratory as a special room for conducting practicals, not so? Then we could also discuss laboratory rules and regulations, looked at safety symbols, looked at laboratory apparatus and their uses. We looked at some specific ones for volume, not so? That's the end of our lesson today. Thank you for being very good students. We meet in the next lesson.